Hi guys. Here we are trying this online thing, and like I said, I've done this before, but I haven't done it in a while. So let's see how it goes. So I'm just going to teach the lesson like I normally would if we were in class. I have my notebook lesson here, and I'm just going to write and talk. Hopefully you can follow me, and you can post questions through Google Classroom. Okay. So the do now is something that you should already know how to do. But we'll go through it together. So we're going to do the do now. Let me see if this is going to write for me. Yes. Okay. So to simplify square root of 45, we know we need to find a perfect square that goes into 45, which is 9. So I can rewrite this as square root of 9 times square root of 5, and we can simplify that to 3 square root of 5. When you're multiplying two binomials, obviously, that's going to give you 6x squared minus 10x plus 21x minus 35, and we can simplify that to 6x squared plus 11x minus 35, right? And the reason I'm going over these things is because we're going to need these skills to work with complex numbers, because that's what we're starting. You know, I'm sure a little bit about complex numbers with you learned it last year, but we're going to go a little bit more in depth. And here, to solve this following equation, the quadratic, we can do it one of two ways. We can add 9 to the other side, which would give me x squared equals 9. Then I can take the square root, which is going to give me plus or minus square root of 9. And then we also know that that's plus or minus 3. And we know there's two solutions with a square root, right? Because there's a positive and a negative answer we have to consider. You can also factor this, right, into x plus 3 and x minus 3 equals 0. And then I could find each of my solutions this way. X plus 3 is going to give me a 0 at negative 3, and x minus 3 is going to give me 0 at positive 3. So you see both ways I get the same answer. Okay, so just a quick review of that. Let's move on to the next slide. So we're talking about the imaginary unit. You can pause right now and read this if you'd like, so that I don't spend time on this, but basically we're talking about I being equal to the square root of negative 1. That's important. And then obviously if that's true, then I squared is equal to negative 1. Okay, so we're going to be using that to simplify complex problems and to be able to find complex zeros. All right, moving on to the next slide. This is just a way that we can classify all the numbers. You guys know about real numbers here, right? And real numbers are broken into rational and irrational. And under rational numbers, we have integers and whole. And then all the way over here, we have another category for imaginary numbers. And this whole thing falls under the complex number system, right? So complex numbers are separated into real and imaginary. Imaginary numbers are in their own subset by themselves, and then real numbers are broken down in the following way. Okay, this should be a review. So simplifying now radicals with a negative, we now can do that because we know that the square root of negative 1 is equal to I, right? So this I can rewrite as the square root of negative 1 times the square root of 9. And we know square root of negative 1 is equal to I, and this is equal to plus or minus 3. So I know this is going to be equal to plus or minus 3I. Similarly, for this square root of negative 81, I'm over here. Again, I can rewrite that as square root of negative 1 times the square root of 81, and that's going to give me plus or minus 9I. Those are easy because 9 and 81 are perfect squares. However, square root of negative 27 is not. So I can rewrite that as the square root of negative 1 times the square root of 9 times the square root of 3. Again, this can be rewritten as plus or minus 3I. And the square root of 3 I can't do anything with, so I'm just going to leave it alone. And similarly with square root of negative 8, I can simplify that into the square root of negative 1 times the square root of 4 times the square root of 2, right? 4 is a perfect square. That's what we're trying to find, a perfect square that goes into 8, which is 4 in this case. So then I can rewrite this as plus or minus 2I, and the radical 2 I can't do anything with, so I leave it, okay? So that's how we simplify radicals with negatives underneath. We have to use I in those situations, okay? The imaginary unit I, we can also add real numbers to real multiples of this imaginary unit, and that's in the set of complex numbers. Each complex number can be written in standard form. So this a plus bi is very important. Standard form, because I will ask you, anytime you're adding or subtracting or multiplying or dividing complex numbers, they have to be written in the correct form, which is this a plus bi, okay? So in the standard form of a plus bi, a is called the real part. See, that's important. And the bi is considered my imaginary part, okay? So there's two parts to this a plus bi, right? This is my real part, and this is my imaginary part. And when I combine them together, that makes a complex number. Just like in the diagram that I showed earlier, how the complex number system is broken into real and imaginary, two subsets. So this is my real part here, and this is my imaginary, okay? So just like real numbers, I can add and subtract complex numbers. So here I'm going to add my real with my real, and I know it's addition because it's plus here. So I'm going to add 4 plus 1, and then I'm going to add 7i plus negative 6i, right? That's going to give me 5, and this is going to give me a positive 1i. So this is my final answer here. And similarly, now I'm subtracting, so I have to be mindful of that. 1 minus 4, I'm doing with my real part, and then I'm doing 2i minus a positive 2i. That's going to give me negative 3 plus 0i, basically, which is equal to just negative 3. So my imaginary part canceled out, right? I'm just left with the real part. And here, this is a little bit more involved, so I have to distribute my negative. So that's 3i plus 2 minus 3i minus 2 minus 5i, and then I'm going to combine all my like terms. So I have a 3i here, a negative 3i, and a negative 5i. These, the 3i and the negative 3i will cancel to 0, so I'm left with just negative 5i. And then the real part, I have positive 2, and I have negative 2. So my real part also cancels out, so I'm left with just negative 5i. So I only have an imaginary part. So I hope everybody's understanding this. And again, you can post questions in Google Classroom. Sorry, I'm kind of going fast because I can't make the video too long. All right, here we can multiply also. So 2 times 4, we're going to use distributive property, right? So I'm going to do 2 times 4 is 8. 2 times positive 3i is positive 6i. Negative I times negative 4 is negative 4i. And then negative I times positive 3i is negative 3i squared. So we have to be careful with this squared here. 8, I'm bringing down my 8. These I can combine because they're like terms, so that's going to give me positive 2i. And remember what I squared is equal to? It's equal to negative 1. So this is actually negative 3 times negative 1. That's positive 3, so I'm going to have my plus 3 here. And then I can combine these because they're like terms now. So I have 11 plus 2i, and it's in a plus bi form, which is what I want. So my real part is 11, and my imaginary part is 2i. Here, 3 plus 2i squared, we're just multiplying that times itself. So that's going to give me 9. And then I'm going to do plus 6i plus 6i plus 4i squared. Be mindful of that squared there. So then that's 9 plus 12i. And this is going to give me negative 16, right? Because I squared, remember, is equal to negative 1. So that's going to give me... oh, sorry, not negative 16. My bad. Let me erase that. Not negative 16. It's going to give me negative 4. Right? Because I squared is negative 1 times positive 4 is negative 4. Then I can combine those. This gives me 5 plus 12i. Okay? So I think I'm going to stop here for now. Well, actually, let me see. Let me try to keep going quickly. A complex conjugate, basically, if I have an a plus bi complex number, the conjugate is a minus bi. Just be careful that you understand that just the imaginary part changes sign, not the real part, right? So it's not positive I to negative I. Just the bi changes sign, right? Just the bi changes sign, okay? So be careful of that because a lot of students make that mistake. Changes sign, I meant to say, sorry. Okay. Changes sign, okay? So keeping that logic, we're going to multiply each complex number by its complex conjugate. So the conjugate of this would be 1 minus I. And you're going to notice what happens. I'm going to let you do it. When you multiply these, you're going to find out that by doing this, the imaginary part cancels. It goes away. And in certain circumstances, when you're dealing with complex numbers, we want that to happen because it makes our life easier. Again, here, when I multiply by the complex conjugate, it's going to be 4 plus 3i. So I want you to multiply this and see what you get. And then here, since it's just the imaginary part, I'm going to just be multiplying by negative 3i. Okay? And let's do those. You can pause here and work those out and see what you get. And here, you know what? I think I'm going to pause here, and then I'll come back with another video tomorrow.